Hey math kids, today we're going to talk about optimization, and this situation is we have a flat tin rectangle that's 40 centimeters by 25 centimeters, and we're trying to make it into a cake dish. And so what we're going to do is cut out squares from the corners and fold them up to make a three-dimensional cake dish. So the first thing we want to do is find the actual length of the cake dish, and we're trying to optimize the volume is our goal. So this entire length is 40, but then we're going to take out an x on each side. So this length would be 40 minus 2x. Similar thinking, the total length is 25 and then minus 2x. Volume is length times width times height. And so the length is 40 minus 2x. The width is 25 minus 2x. And then the height is just x. Distribute that. Okay, if we do that, that's 1000x minus 80x squared minus 50x squared plus 4x cubed. Okay, so combine like terms. That's going to be centimeters cubed. Okay, so we found the volume. Now we need to optimize the volume. But before we do that, let's talk about what is possible. So this x could only theoretically come to the halfway point. So the maximum that x could equal on this side is going to be 20 centimeters, because we would cut in 20 centimeters, cut in 20 centimeters, and then we wouldn't have anything. Similar thinking right here, it's 12.5 for x. And so whatever the lowest of the maximums are, that's what our max is going to be. And obviously x can't be any less than 0, and so x has to be defined this way. Okay. Now, what we're going to do is take the derivative of this, because we're hoping that we get some curve like this, and then whatever the max value is, that's going to tell us what x should be. And to do that, we know that the derivative equals 0 at maximas and minimas. So this is going to be, so if we do dv dx, we get 1000 minus 260x plus 12x squared. I'm going to rewrite the order on that. So I'm going to do 12x squared minus 260x plus 1000. If we take out a 4, we'll be left with this. And then if we t-factor, or we can't t-factor, we need to do box method. So we do this times this, we get 750. And we're trying to make 65, so let's try 75 and 10 probably works. Minus, that works. But it doesn't add back up to that. So that one doesn't work. Let's try 50 and 35. Wait, that doesn't even work. Okay. 50 and... Alright, I'm drawing a blank. So let's just go through it systemically. I was trying to cut down on the time, but... So we have 1 and 750, 2, 375, 3 will work as well. $250. Oh, I should have known that. That's how I made it. 4 won't work. 5 will. That's $150. 6 should work as well. $125. I don't think 7 will work. 8 won't work. 9 won't work. 10 and 75. 11 I don't think will work. $15 and $50. Alright, there we go. That's the one we want. If we make both those negative, they make 65. Do our box. 3x squared, 250, negative 15x, negative 50x. Factor things out. That's just an x. Okay. So we're just going to divide it by 5. Okay, so we get 50. Just 5. It's going to be negative 5 because we have these diagonal negatives. This is 3x, and this is 50. Once again, diagonal. Okay, so we write that in factored form. Once again, we want, this is the derivative, and we want it when the derivative equals 0. So x minus 5 equals 0. 3x minus 50 equals 0. We add 5, x equals 5. We add 50, 3x equals 50. Then we divide by 3, and we get 50 over 3. Alright, so 50 divided by 3 is about 16.6 repeating. Now, we're going to throw this out because it's not within this range. Okay. Now, so x equals 5 is going to be our maximum volume, assuming that this is a maximum. So we need to make a sign diagram from 0 to 12.5, then we have our 5. So I'm going to choose 1 and 6, plug it in right here. If I plug in a 1 here, it's negative. Plug in a 1 here, it's still negative. Negative times negative is positive. If I plug in a 6 here, it's negative. Plug in a 6 here, it's now positive. Wait, is that right? No, that's not right. I need to... Oh, that's because if I plug in a... I messed up right there. If I plug in a 6 here, it's positive. If I plug in a 6 here, it's negative. Positive times negative is negative. Alright, sorry about that. Okay, if we're going up and then down, that is a max. And so x equals 5 is a max. And so that is the maximum. We'll get the maximum volume if we use x equals 5. I think that's what it's asking for, not what was the volume. What size squares must be cut out to produce a cake dish of maximum volume?